Hello, welcome back to the lecture series on application program of the Internet Protocol. In this video, we are going to learn about the very important socket programming that is used for client-server application programs. What is the agenda? I will introduce you to socket, the meaning of socket, why it is used and how it is used. Then I will introduce all of you to socket programming, the basic concepts of socket programming. After that, socket programming client-server communication. Then socket programming example. I'll show you one example, which is the echo example. So, introduction to socket. Now, what do you think a socket is all about? A socket is an endpoint for a communication between two entities. If you are dealing with a client-server application program, if this is the client and this is the server, there has to be a communication path between them. And this endpoint is also called the door, is known as the socket. So here also at the server side also we will have a socket. So socket is a requirement for communication between two entities. So what is a socket all about? To understand, it is an abstraction for sending and receiving by an application program in a client-server application. It is basically a generic access to IPC. IPC stands for inter-process communication. Now, whenever there is a communication between two processes, a socket is required. So, we call it end-to-end communication. Now, these two processes can be in a single computer or it can be between two computers C1 and C2. So what are the different types of sockets? There are 4 different types of sockets: stream sockets, datagram sockets, raw sockets, and sequenced packet sockets. The stream socket uses TCP connection and it has a sequence number. So sequencing is possible. Let's say we are sending packets A, B, C, D one by one from one endpoint to the other endpoint. So since we have done a path setup, so all these packets will move through the same setup path and it will reach the destination. So at the destination also, we will get the packet in this order. So this is known as a stream sockets. Datagram sockets use UDP or user datagram protocol, and it is unreliable and connectionless, unlike stream sockets, which is connection oriented. Raw sockets are similar to datagram sockets and they use UDP protocol, but here they are mainly used for developer for developing new applications, or they can be used to move into some of the cryptic areas of existing protocols. And these sockets are not used by any general user. Let us now turn our attention to sequenced packet sockets. These are like the stream sockets. They use TCP, but only difference between the stream sockets and the sequenced packet sockets is that the data records has some boundary. Here the data records will have no boundary. So this is the pictorial representation of the socket that is formed between two hosts, host A and host B. You can see here, socket basically is the interface between the application layer and the TCP layer or the transport layer. So the application layer, the packet from the application layer comes to the TCP layer through the socket, and it moves through the channel, and it can pass through a router and then can go to the host computer. Again, it moves from the IP layer, then the TCP layer. Again, it comes to the socket and then moves to the application layer. What are the parts of a socket? A socket should have an internet address. To recall, in order for a packet to reach a destination, we must have an IP address. This IP address can be IPv4 or IPv6. We are at present concentrating on IPv4, which is 32 bits, having 4 bytes. Next, there should be an end-to-end protocol. Like whether we are using the TCP protocol or the UDP at the transport layer or not. Then a port number must be identified. It is like the unique I/O facilities. In order to design a socket, we must use the file descriptors. If you recall, for Unix, the file descriptor is an integer which is defined for an open file. Now, this open file can be a text file, it can be a terminal, it can even be a network connection, etc. So just like Unix I/O facilities, we use here file descriptors, low-level file descriptors. Then we use the read-write system calls. Let us understand the pictorial representation of a socket having different applications. So these are the applications. From the applications, we have either the TCP sockets or we can have the UDP sockets. Then from the application, we have the descriptor references, or we call it the file descriptor references. Then this sockets move to the TCP ports. There may be ports from 1 up to 65535 number of TCP ports. At the same time, we can have the UDP ports here, starting from 1 up to 65535. Now, this UDP sockets or the TCP sockets are bound to the ports. So this is the UDP layer, this is the TCP layer, and below we have the IP layer, which is the network layer. So this is the overall representation of how a socket looks like and what is its place in the OSI model. Let me now introduce you to socket programming. We understand the client-server communication. We know that socket programming is required for making a client-server application program and to make a communication between two endpoints. Let's say we have a client. A client program is a program which always asks for a request from a server. This client socket should be an active socket because it is the one which will initiate the process. It will initiate the process by initiating the communication. It will give the IP address and the port of the server. This IP address and the port of the server are known to all, but it is not necessary that the server knows the IP address of the client. Next, we have the server. It is a passive socket. It will act only when the client makes a request. Upon receiving the request, the server will work upon it and find out the result and respond to the request through that socket. So basically, it has to wait for the client request and response to the client request. What are the socket procedures? Let's understand them one by one. Initially, you have to write this socket in order to create a new endpoint for communication. This endpoint can also be considered as a door for communication between the two entities. Then there is a system call which is called bind. In order to bind, we have to add a local address to the socket. Then there is a listen system call which announces the readiness to accept a connection. Then we have connect call attempting to set up a connection. Then there is a accept. It is used for blocking the caller until a connection request arrives. Then there is receive. It receives data over the connection. Then there is a send system call which sends data over the connection. And ultimately, we have to close the connection by using the close system call, which will ultimately release the connection. Now let us understand socket programming, client-server communication, TCP versus UDP. For TCP, we are using the stream socket, and for UDP, we are using the datagram socket. So initially, let us understand the server side. And this is the client side for the streams TCP. And similarly for the datagram UDP, we have the server side and we have the client side. So initially to make the server, you have to create the socket. Then after that, you have to create the bind to add the local address. Then listen, waiting for communication. Then accept, because here the client has to be created using the socket, and after that it has to create a connect system call in order to make a connection to the server, and the server can accept the system call of connect from the client at the synchronization point. Then it is the server who is receiving and the client is sending the request. Server is receiving the request. Then server can send the response. In this fashion, it can move on either in the TCP or in the UDP. You notice one thing, in TCP, we have to create this listen and accept. But here in UDP, since it is connectionless, we do not need to create that. At the end, we can close the connection or release the connection by using the close system call. So let us understand how to write the socket system call. So the formation of the socket is, you have to write an integer. So this is a file descriptor sock ID, which is an integer number. So this is the formation, socket, family, type, and protocol. Next, how to write the bind. So integer it is also integer, status, then bind, sock ID. It is the address of the port and the size. Next is the listen system call. You just write like this, integer status, then listen, sock ID, and queue limit. Queue limit is given to understand what should be the queue length. Then there is a accept and connect system calls. For connection, the client is making the connection. So in int status connect, then give the sock ID and the foreign address and the address length. The server will accept it with the sock ID and the client address and address length. Next is the send. You write it like this, int count, then send, sock ID, message length, and flags. And for receiving, you write int count, receive, sock ID, receive buffer, buffer length, and flags. For the send to, that means this is for the datagram. It is int count, send to, then sock ID, message, message length, flags. It's a foreign address and the address length. Similarly, for receive from, int count, receive from, sock ID, receive buff, then the buffer length, flags, client address and address length. Then how to close the connection? Just write status equal to close sock ID. So that will create a socket, then transfer messages between the server and the client and ultimately terminate the connection. Let us understand one example of socket programming, and is the echo example. Using the datagram socket UDP. Communication with an echo server is done with the help of a client, because client will be making a request to the server. The server will echo the received message back to the client. So this is the example. So what will happen at the client end? The client will create initially a UDP socket, and at the same time the server will also create the UDP socket. Client will assign a port to the socket. Server will also assign a port to its own socket. Client will initiate the communication, so it will communicate with the server, and the server will repeatedly communicate until the client closes the socket. Because here there is a client which will send a message. It will go to the echo server, and the server will continuously echo back the message to the client until the client closes the socket. Now this is using the stream socket or the TCP. Again, we are using the echo server. So client will initiate the communication and the server will echo back the received message to the client. So what will happen here? The client will create a TCP socket. The server will also create a TCP socket. The client has to then establish the connection, because this is a stream socket using TCP. So you have to set up the path. At the same time, the server will assign a port to the socket. Then the client will communicate and server will set socket to listen mode. Then client can close the connection, but server will repeatedly accept new connection, communicate, and then it will close the connection. So this is an example using stream socket for the echo server. To summarize, in this video we have learned the meaning of socket, where it is used and how it is used, and we have introduced the audience to socket programming. Socket programming example with TCP, we have used the echo server, and then we understood socket programming example with UDP. Similarly, we used here the echo server as well. Thank you.